In tonight's webinar, we're going to discuss a few things that you've probably got quite a lot of questions about. We're going to provide you a definition for what is chemical process engineering. We're going to talk about some of the career opportunities that exist in chemical process engineering. We're going to talk about the structure of the chemical process engineering degree at UTS, and we'll also talk about the UTS applications process, and we will also hold a question and answers or Q&A session. Okay, so in terms of the background, chemical process engineers are experts in using raw materials and energy and to turn them into value-added products, and those products need to be functional, safe, and sustainable. So when you sort of think about the chemical products that we've got in society, if we're interested in creating a safe product, we're looking at potentially, say, a pharmaceutical or medical application, or it could be an explosive that's being manufactured, for example. If we're talking about sustainable products, then we might be talking about some sort of energy systems product or a packaging product, for example. Whereas, functional products will come into play for the advanced manufacturing industry. So that's in a nutshell what chemical process engineers do. And at UTS, studying chemical process engineering enables students to sort of bridge two worlds. I mean, you've got fundamental engineering science, but you also get to apply that with emerging digital literacy skills like artificial intelligence and data engineering and Industry 4.0. So by bringing those two worlds together, we're putting students in a position where they can, make a really strong contribution to chemical process engineering. So, I mean, in terms of, working in that sort of plant environment, this is actually an Industry 4 test lab for creating algae. Algae's got a broad range of really useful environmental and chemical applications. So this is sort of like the typical sort of environment that we really anticipate that our graduates will end up working in. Okay, so as I was saying before, with the chemical process engineering degree at UTS, we're really wanting to sort of bring those two worlds together. So the fundamental engineering science that underpins chemical process engineering hasn't changed. I mean, we're still after students who really have a passion for chemistry, they're knowledgeable about physics, and they've also got expertise in biotechnology. That scientific core of chemical process engineering is the same, but to be able to create the value-added products that society needs, we need to bridge that with the digital world. And that's one of the strengths of our Faculty of Engineering and Information Technology at UTS, is that we've got a lot of expertise in those digital literacy skills like machine learning, automation, data science, Industry 4, advanced manufacturing. And by bringing those two worlds together, we believe that we're offering a unique degree experience that prepares students very well for the future direction of the discipline. Okay, and when we do create chemical products, there's a few examples or a few outcomes that we really like to get from those activities. Environmental sustainability is a really, really important one. You think of the current chemical process engineering industry is very largely fossil fuel based. And what we want to inspire in our graduates is to move to more sustainable solutions for chemical processing. So environmental sustainability objectives are really, really important. But at the same time, economic considerations are important too. So by creating these new chemical products, we want to be able to achieve economic outcomes for various industries as well. Okay, so this is an overview of the engineering courses that UTS offer. So today's webinar is talking about chemical process engineering. So that's going to be our new major for 2023. I should also mention that we are a school of civil and environmental engineering, and we do also offer degree programs in civil engineering. This is the one with the blue asterisk. So we offer a civil engineering degree with specializations in structures and construction, and we also offer a degree in civil and environmental engineering, which may be of interest in addition to chemical process engineering as you sort of make your selections for tertiary education as the year progresses. In terms of career opportunities, chemical process engineering is a growth area. Yeah, Dr. Erger did some job outlook analysis before tonight's webinar, and over a 5-year window, we are going to be seeing growth potential in the chemical process engineering discipline. And you can see on this slide that there's a whole range of industries where chemical process engineering graduates may work. A number of industries are listed, but should also mention that in chemical engineering consulting, process engineers or chemical process engineers are employed. Both Peter and myself work in air quality research, and in our professional day-to-day life, we do come across people with a chemical engineering background who undertake those roles for consultancies. There are some opportunities with state and federal government agencies when you think about contaminated sites with hazardous chemicals, doing waste remediation and projects like that. State and federal government agencies do get involved in that sort of work, but should mention that it's largely the chemical processing industries where we anticipate that our students will work. And bioprocessing is a good example. So that's relying on students' knowledge of biotechnology to deliver those sort of chemical products that we were talking about before, like safe and functional pharmaceuticals and vaccines. How do we do sustainable food and beverage products, for example? The energy sector is also a big employer as well, and as I was saying before, our economy is largely still carbon based, and with chemical process engineering, there's an opportunity to embrace renewable energy technology and all of the associated benefits with that. So that sector is going to grow tremendously. Now that we've got a bit more global agreement about the urgent need to reduce CO2 emissions. You'll see that the petrochemical industry is listed there as well. People typically think of oil and gas as products of the petrochemical industry, but there's a whole array of other chemical products that are produced there. But what we're going to see playing out is that bioprocessing will start to overtake petrochemicals in terms of that supply chain for the chemicals that we need. And there's other opportunities here as well. UTS has research expertise, in particular in the circular economy. There's opportunities there, climate change mitigation, climate change consulting. Obviously, the mining sector is also going to be a big growth opportunity as well. When you start thinking about like electric vehicles, for example, we need to use a whole range of rare earth minerals to make batteries or electric motors. So we're talking about elements like lithium and nickel and cobalt and metals on the periodic table like that. So there'll be some really big opportunities in the mining sector to build a career once you've finished your degree at UTS. Okay, one question we quite often get from students is, what is the degree structure? So this is what a Bachelor of Chemical Process Engineering is going to look like. The thing to keep in mind about the UTS program here is that not only are you doing the Bachelor of Engineering in Chemical Process Engineering, but you're also doing a Diploma in Professional Engineering Practice. So what that means is that this degree experience with the Diploma in Professional Engineering Practice is a 5-year experience rather than a 4-year experience. And what I should mention straight away is that what you see with these dark grey bits in stage 4 and stage 8 of the degree are 6-month internships. And that enables students to quite often take paid work as an engineer to get experience for your degree program, and that's embedded at strategic stages within the degree. So that experience there is why we're offering a 5-year degree program rather than a 4-year degree program. You can see everything's color coded here. So the red section of this degree is the engineering core. So they're subjects that all engineering students do. So that covers things like engineering science. I mean, you do some maths, you do some chemistry subjects, you do physics, and then you learn those other professional engineering skills like communication and entrepreneurship, commercialization, innovation, and things of that nature. So that's the red bit. Then we've got this light grey component, which is called the field of practice. So the field of practice is a more advanced stage engineering subject that builds upon what was covered in the core. So that's where you actually start to take specialized subjects within your area. So for a student starting their degree in year one, stage one, the field of practice subject would be an introduction to the discipline, which would be introduction to chemical engineering. And then you sort of move through a whole range of experiences. So that includes chemical process engineering science. So things like heat and mass transfer and thermodynamics and reactor design, and things of that nature. But it also means studying those digital literacy fundamental subjects as well. So we've got industrial data science and machine learning. We've got industry for product development. We've got advanced manufacturing and subjects of that nature. So we're really bringing together those two worlds for this particular degree experience. You'll notice that this grey section is electives. So students in this chemical process engineering degree program have the choice of taking 4 6 credit point electives, and they don't necessarily have to be subjects that the student undertake within the faculty. It may be that the student chooses to take those electives outside of the faculty. And if you have a look at engineering programs around Australia, you'll see that a lot of universities offer broadening electives, and there's the opportunity to do that at UTS. So for example, if you had particular interests in developing business skills, you may qualify to do electives within the business faculty. If you were interested perhaps in commercialization, legislation and things of that nature, it may be attractive to try and undertake, for example, a subject in the law faculty to develop those particular skills. What you'll notice as well, there's a blue bit. So that's what we call the final year capstone project. So you'll see that in year 5, in stage 9 and stage 10, students have the opportunity to undertake a final year research project. So that's your own independent piece of work that you can undertake as part of your degree. And it's quite often a real hallmark feature of the engineering degree experience, where when graduates start to look for employers, they can, show their final year capstone project as a product of work that they've been able to deliver. Okay, just some more notes on the diploma in professional engineering practice. So this is one of the unique components of our degree experience at UTS. So as you saw on the previous slide, we're offering 2 6-month internships in stage 4 and stage 8 of the degree. I think one of the real attractive features of the internship experience is that it enables students to experiment a little bit while they're doing their degree. I think the world is becoming a lot more of a complicated place, and I think it's asking too much for every recent school leaver to know exactly what it is that they're going to pursue career-wise. And we quite often get a lot of feedback from students saying that, well, I tried this first internship and I was working in a particular industry that I thought I was really passionate about, and they get to the end of that 6-month internship and they realize, actually, no, that's not really what I want to do. I'm not really comfortable working in an office, for example, doing designs and doing lots of calculations. And then after that internship experience, students will come back to UTS and study for another 3 sessions in their degree. And then by the time they get to their second internship, they say, well, right, I can try things a little bit different now. I might want to put more emphasis on potentially moving into a more, say, practical role. It could be more related to project management, managing the activities of contractors and emphasizing their communication skills and project management skills. And that's totally fine. And this does happen a lot. But those 2 internships really give students a real eye-opener of what the industry is like in their particular area. And they can graduate with a better sense of what sort of trajectory they think that their career is going to take. So that's one of the really important things here. So rather than offering an engineering program where students have 12 weeks of experience, you graduate with 1 year of experience. Should also mention that UTS has a working relationship with a large number of companies. I think the last time I was querying this. I think we have a database of over 1,000 companies that UTS have a productive working relationship with, and that sort of sets the foundations for the sorts of companies and industries that you can work in. Okay, so that's just a short overview of our chemical process engineering degree program. You may hear us refer to that as CPE in the Q&A. I'm going to hand over again to Danielle for the remainder of this presentation.
Thanks, Nick, for that in-depth insight into chemical process engineering. So we'll just run through a few quick things to help you with your course applications. Adjustment points for UAC rounds. So the points themselves are added to students' raw ATAR to give them what we call a selection rank. These adjustment points are capped at 13 total at UTS. The adjustment points can be given for a number of factors. These factors can include completing the UTS Engineering and IT questionnaire, good results in relevant HSC subjects, your gender and special circumstances, and more. If you'd like to find out more about these adjustment points, please scan the QR code on your screen now to be taken to an in-depth page with these details. Next, we'd like to go through the UAC Key Dates. As you can see, this is just a summary of the different dates that will come between now until the peak period of HSC exams. We have scholarships now available that are open and will be closing mid-September. We have our key date open day on the 27th of August, and hope that we might be able to join us then to help answer any further questions you might have. And we also have all the different rounds in which UAC offers different course release sessions, and also that the ATARs for New South Wales and ACT is likely to be executed in mid-December. Please note that these dates are subject to change, and you can find out more at the UAC Key Dates page just listed on this screen below. The UTS Early Entry Program. So the program itself is currently available for domestic students in Year 12. You can apply through an online application that's different through UAC. It's free to apply, and applications are likely to open in June and July and close in September. These dates are yet to be confirmed, but we'll provide this information as soon as possible. The offers themselves are provisional offers, which means that you'll receive a conditional offer before the HSC commences, but you must complete your HSC or equivalent to get the offer itself. If you'd like to find out more, you can scan the QR code on your screen now to get more information. Student support. At UTS, we have a number of student support opportunities. We have our bridging courses offered in mathematics, physics, and chemistry to help support you while studying and to get you prepared. We also have a system called UPass, which stands for Peer Assisted Study Succession, and it's available for some subjects, and the great thing is it's supported by students who have previously undertaken the course and are years ahead of you, so they have gone through it and can help assist you where needed.